Good morning, everybody. I believe we can start now. So just confirm if I'm audible clearly and my screen is visible.
Yes.
Okay, thanks for confirming. So the agenda for today is to take the design patterns further. There were a couple of creational patterns left, and then we'll be moving on to structural patterns. So creational patterns, prototype, and singleton is something which we didn't discuss about, and then all the structural patterns, which include adapter, bridge, composite, decorator, facade, flyweight, and proxy. So that's what we'll be looking at today. So if you remember, we spoke a bit about the prototype. And even if you go by the dictionary meaning of prototype, probably you can understand what exactly it must be. In general, if I talk about what is prototype, what what would be the answer? Can I say this? It's some working model of some other object or exact copy. Yes or no?
Yes, yeah.
Possesses exactly same properties, exactly same data members, exactly same functionality, right? So mostly the term comes up in real life when we are looking to invent some new object or build some new object, and we want to first of all create a model uh, object of it. We want to do all the testing on it, and then once we are satisfied with everything, probably which will require multiple revisions and rework multiple times, based on which we will be having a proper concrete product created, and then that design needs to go into the production where it is mass produced. And that's where we use the term prototype for the initial model that we create. Correct? Yes. It is other way around. That's a master object that we build initially. And then the mass production happens. And the mass produced objects are actually the prototypes of the original model. Right?
Right, yeah.
And logically, if we think it is that way. Yeah. Now, the purpose of all this activity is to stabilize some object, its behavior, everything related to it before it is actually mass produced or mass used. So that once it goes into the mass usage, there will be no further issues. Correct?
Yes.
That is where we got the terms like beta testing and alpha testing and all that also, right? We produce something which we allow the end users to work with, test it, and then once we think that yes, all positive reviews are there and the product looks stabilized, it is actually released. Yes. the, the entire concept of this pattern prototype is revolving around the same concept. Many a times we create objects which might have some complex data structures, complex functionality to operate on those data structures, and probably to create the same objects or same family of objects later on might involve a lot of cost. So when it is a complex data structure, a lot of memory management needs to happen. And for that, if we are creating the object from the scratch every time, the processor time is going to be involved in finding out how much memory is required, how much memory needs to be allotted, and then the actual memory allocation happens. Whereas if we already have a working copy of that object and we are saying that create a prototype of it, all calculations have already happened in the past. We just need to scan the object requirements and allocate the memory accordingly. And the object can be immediately created pretty easily, right? So it's as good as Aadhaar card. If you are getting it downloaded from the Aadhaar website, UIDAI website, there is a process, right? You log in with OTP, and then you say download, then again OTP comes. Long process is there. After that, you have to print. But if you already have a copy, printed copy with you, you just need to go to any Xerox machine and you have to get it copied. It's much more faster, much more easier. Ink consume will be the same, paper cost will be the same, but the time and efforts required to download and then print will be saved. That is exactly the same thing applicable for complex objects also with complex data structures. Make sense? So let's see the UML diagram for it first of all, and then we'll see the implementation. Have a look at this. This is the ultimate user application. Okay, having the object created, and then there is a prototype interface which they are using to create the object. Deep copy, and then there has to be concrete implementation of the same. So the moment we call the clone method, the copy, the deep copy of the current object is returned. Probably this contains the statement like return this. This is the keyword that points to the current instance of the object, right? Yes. So something like that gives me the separate memory allocation for the object pretty easily. This clone is responsible for that. Okay. Let's see the example. For that, we'll need Visual Studio to be opened up. And most likely it must have the solution already listed over here in recent category, or else you can just go for open a project or solution, search for the location where you have created your folder. So I guess it's on desktop. There we created a folder by the name Quinnox, demos, C sharp, and there we have CS demo, GOF patterns, and here is the solution. So your solution is open. We created 3 different demos into this abstract factory, builder, and factory, right? And currently prototype also belongs to this category only, creational category. Hence, we'll be going to the creational folder and we'll be creating a new object out of it. Okay. I mean, a new project into it. So let's right click on creational folder and say add new project. This is the 4th one. So I'll start with console app here, then next, and then the name starts with 4 underscore prototype as the name. And next, .NET 5 is what we are using, create. So there we get the sample stuff. Let's get rid of this console.writeLine hello world. Done. Just before the class program, let's add another class, which will be an abstract class. So let's say public abstract class. Let's name this as prototype. It has got a data member of its own. Let's say ID. Let's make it private as well. Though even if I don't give it is by default private, but this makes the code more readable and easily understandable, right? And I want the property in read-only mode to be created. So it will look like this. Public string ID, curly braces, get. What it does is returns the ID and no set block. That means this property is going to be read-only property, which means I can only read ID. I cannot set the ID. Got it? And then I have a constructor over here. So I just type CTOR, press tab twice. Automatically the constructor is created here. This takes in a string parameter by the name ID and assigns to this dot ID. So far, it's a simple class structure, right? A class with a single property, single data member, and a constructor. And this class being abstract means it must be having some abstract member. Here goes that abstract member. Public abstract. What it returns is the object of this class itself by the name clone. The method exists. Okay. Is it done? Yes. Shall I proceed?
Yes.
Yes.
Next comes the concrete implementation of it. So public class by the name concrete prototype I create. Couple of concrete classes I'm going to create. So I'll say concrete prototype 1 is the name that inherits from prototype. Now this being the abstract class, giving the error here saying that this class doesn't implement the abstract member clone. Here we use the slide bulb and say implement abstract class. So automatically it overrides the clone method. Now, typically when I say clone, it is always going to be a shallow copy. And if I say copy, it is going to be a deep copy. Now, what is shallow copy? What is deep copy? If there is an object, person, by the name P1, if I want to create P2, which stores the reference of P1 only within it, so that if I make changes to the P2 properties, they actually get changed for P1 as well. That's where I go for clone. But if I'm looking for two different objects altogether, I go for deep copy. And in that case, I need to have a method called as copy. Is it clear?
Yes.
Okay, so let's put a comment over here used for shallow copy. In this example, we'll be using shallow copy only because prototype actually is about that. Okay, and then here I say return this dot member wise clone as prototype, because the return type of member wise clone must be object, as this method is inherited automatically from object class only. So what I'm doing is I'm casting it back to prototype and returning, because the return type over here is prototype. Is this clear? Yes. Now still there is some error. That is because here we have a constructor in the base class which is parameterized, and here we don't have a parameterized constructor which change to this. So technically this class cannot be instantiated without passing this parameter. What does it mean is I need to have a constructor with a parameter that satisfies at least ID, if not more. So here I say it takes in string ID and change to the base class constructor with this. So I say base ID and it just does its job. Okay. I need a second concrete prototype as well. I can have as many prototypes as I want, where I can change the behaviors as well. I can add some more members, data members to the data structure as well with this. So let's say I have concrete prototype 2. I just copied and pasted concrete prototype 1, changing the names here for the class, for the constructor. Rest all remains as it is. Okay. Then in main method, I create the instance of concrete prototype 1, P1 equals new concrete prototype 1, and I pass the ID as I, Roman number I, so that represents 1. Then I say concrete prototype 1. This is the clone, so I name it as C1 equals P1 dot clone. The error is this is returning the object of type prototype, and here I'm looking for concrete prototype. Parent class cannot be assigned to the child class instance directly. We have discussed that in the earlier sessions. So I need to explicitly typecast this to concrete prototype 1. So I say as concrete prototype 1. And there I say console.writeLine, the interpolated string cloned colon curly brace C1 dot ID. Okay. And then same thing I try with concrete prototype 2 also. So I just copy these 3 lines of code, paste them back here. Do the renaming. This is concrete prototype 2 Here also this will be 2. This is P2. This is C2. This is concrete prototype 2. This I'll say double I. That represents 2. This is P2 dot clone. Hence, this type is going to be concrete prototype 2. And here also it should display the ID of C2 object. Let's start. So here comes the message. Is it clear? Yes. Yes. So let's close this and let's move on to our next pattern, which is singleton. Singleton, most of us are aware of already. What is it? Someone already defined this in the last session, last to last session rather.
It
It's all
creates
about,
only.
yeah, it allows only one instance of the class to be created, right?
Yes, yes.
If someone asks for the new instance to be created further and the first instance already exists, it just returns the copy of the same, right? Not exactly copy, it's a reference of the same. So somehow it promotes the use of cloning. Am I right? Rather than saying promote, it mandates the cloning process. Whenever you need an object, if there is no object created, you create it, but after that, you have to always clone it as far as at least one object reference is present. Correct?
Yes.
Yes.
Okay, so let's create the example for the same. Again, under creational, I'll say add new project. Console app, next. I'll name this as 5 underscore singleton. Next, .NET 5 is the framework. Create and remove console.writeLine statement. Okay. And then let's create the class called as singleton here. Public class singleton, which has got a private member of its own type, singleton, that actually represents the instance that has been created. If this instance seems to be null, that means there is no single instance present. But if this instance has got a value, that means the instance is present, return that only. If someone is asking to create a new instance, right? Then we have the choice of making the constructor either as private or protected. Usually private if this class is further not going to be subclassed. But if you are going for subclassing means inheritance is planned, probably you might need to change the behavior of the constructor a bit in the subsequent inherited classes. That's where instead of making the constructor private, it is suggested to make it as protected. We know that even protected members are not accessible directly via the instances, right? So for the object instances, protected members also behave just like private, correct? And then we need to have a static method which actually takes care of object creation. So here I say there is a public static member method called as instance, which returns me the object of this class itself, that is singleton. So I say public static singleton instance. What it actually does is checks if instance is null. What's wrong here? Oh yeah, this needs to be static because we are in a static scope, right? So instance members directly cannot be accessed. Okay, so if instance is null, I'll say set up the instance to new singleton object. Otherwise, instance is already initialized. So in all cases, when I say return instance, at this place, it's guaranteed that we have an instance. And being this member as static, this member will be created only once. There will be no multiple copies of it. So this logic will make sure that one and only one instance at any moment of the time will be present for this class singleton. 0 or 1. If this class is not used at all, there will be 0 instances. If this class is used once or 10 times or 100 times or 1000 times, there will be still one instance only. Yes.
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 Now let's go to the main method and try creating the instance. If I say singleton s1 equals to new singleton, it won't compile. Reason? Constructor is not available, it's protected. It simply says the constructor is inaccessible due to its protection level. I cannot use this. So what is the way? I have to go and say singleton dot instance. I have to request the instance like this only. Same way I create another instance, let's say by the name S2. And then I want to compare these two objects if they are same instance or they are two different instances. So here I go and check if S1 is equal to S2. Means if they are the same objects, they contain the same reference or not. If they are not the same references, the body of if statement won't execute. If they are containing the same reference of the object, then the body will execute, which displays the message both objects are actually the same instance. Got it? Let's run this. And it says both objects are actually the same instance. That means both are having exactly same reference. Means they're pointing to the same memory location. Means though we have two different objects, they are actually At the memory level, they are actually the same objects. Just two different aliases are there, S1 and S2. Yes?
Yes.
Okay, so that is what the creational patterns are all about. You have seen all the 5 creational patterns, which are all about how the objects are created or constructed. Am I right?
Yes.
Yes.
Let's move on to the structural patterns now. Structural patterns, what they are? What we discussed? Anybody? If remember?
We use structural patterns to design multiple objects in a same group.
Same group. So can you elaborate that?
Uh, like if the objects have relation in between them, so we can use the structural pattern.
Yeah, correct. So it is all about the relationship between the objects, right?
Yes.
Many a times we probably will come across some objects which are related to each other. Say, for example, if I talk about the HR management system, and within that, if I'm uh, looking for the possible classes, there would be a class called as department, there would be a class called as employee, and there will be a relation between these two. Yes or no?
Yes.
Right? So probably this relation also will come in one of these structural patterns, maybe two of these structural patterns, right? It is almost similar thing what we usually see with respect to the RDMS based databases. There also we talk about relationships. Yes or no? So based on what exact kind of relationship is there, we decide which pattern is going to come into picture. It could be one pattern, it could be two or more patterns also, right? Because as I said, patterns are kind of atomic problems with their solutions, but in your case, they may not be applicable as it is. There might be a combination of multiple patterns required in some situations to get your solution. Am I right?
Yes.
Right. So here the patterns which come under this category, structural patterns. There are total 7 patterns in this category, starting with adapter, going forward to bridge, then composite, then decorator, then facade, then flyweight, and then proxy at the end. Probably some of these names we are aware of from our day-to-day life, and we can actually predict what these patterns must be about. So for example, if I talk about adapter, what it is, might be some kind of logic which contains some kind of transformation or conversion from one object type to another object representation. Yes or no? Might be required when we are connecting two discrete systems. I have some common data, but there is no common interface between the two systems. And some sharing is required, some logic needs to be shared. How will I do that? Most likely I'll come up with some adapter logic. Yes or no? Which takes an input from one application, converts it to what the other application understands, and makes the call accordingly. Yes?
Yes.
Say what your laptop or mobile charger does, converts AC to DC. Inverter converts DC to AC. These are all practical real life implementations of adapter only. And that's where we use the term adapter practically. Yes or no?
Yes.
Bridge might be something about connecting two different objects in order to make them communicate, having some common interface in between, right? And proxy is another thing which is very commonly used. An object interface representing some other object, right? We know the proxy. Even if we have worked with proxy classes, some client server architecture, we use the proxy classes a lot there. So by default, we use the proxy pattern there. Yes or no?
Yes.
With proxy, the real object, which might be a very complex implementation, need not be present for the call to be made. There might be a lightweight version of it, termed as proxy, might be present, which facilitates the call and server probably receives it and processes it. So on server, it will be the real object. On client, it will be represented by its proxy. Am I right?
Yes.
And then there are other patterns also. Let's start with the first pattern, adapter. We already discussed what adapter is all about. Transforming one object interface into the interface of another object. Maybe the clients are expecting one interface, but your object is of another interface. So adapter will help you to convert one interface type of the object to another interface type of the object. Yes or no?
Yes.
Here is the UML diagram for the same. This is one of the object. This is the other object. Probably you can say this is the actual object being requested by the client. Very specific request is coming. And then this is what is available to the client. Client is making the call here via this object. So the interface doesn't match. You can see the two different names are there. Request is what client is saying, but the object contains the method called a specific request. Like there could be a method called a save. Now, whether it is save department or save employee, I don't know. Whichever object I've called save on, it should be saved. But the actual method needs to be called because the save employee method knows how to save employee in database and save department knows how to save in database, how a department in database, right? Different insert queries will be there. So that's where the adapter comes in, which transforms this call to more specific call, generic call to more specific call. Got my point? Yes.
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 Let's see the example for this. Once again, now we need a new project. Serial number will be 6 here. Or maybe we can just restart the numbering here for each of the category. So collapse creational. Now right click on structural folder and say add new project. Console app. Next. For maintaining the proper sequence, I'm actually using 6 over here. Underscore adapter. Next. .NET 5 create. Remove console write line statement. Okay. And then here I create my first class, adaptee, based on that UML diagram itself. Here I have the member method public void specific request, which displays the message on the screen called specific request. This method contains the code simple as this or a very complex code, that doesn't matter. Your actual code will depend on your actual application's requirement. Am I right? Yes or no?
Yes.
I don't want this adaptive class to be exposed to my end users or the clients. So here I create a class called as adapter, which contains a private instance of the adaptee class equals new adaptee. And then let's say I have a method public void request. What it does is it calls the specific request method on adaptee object. Internally, it transforms to the actual request. Now, this adapter should not be again directly used. I need to have my local representation for my client. For that, in between adaptee and adapter, I introduce another class called as target. Again, going by the UML diagram only. Here I say public virtual void request, which displays console.writeLine called target request method. Okay. Done. Now in main, I create obviously the instance of target class. Target equals to new target initially, maybe just to test my local functionality. And I say target dot request and start. So I expect an object, output called target request. But if I say this is going to be an adaptee, instance of adapter, in fact, not adaptee. Little changes I need to make here. I need to say this class adapter inherits from target means extends target and overrides the request method. So here I put override keyword, and that is why I made it virtual over here. So there is no problem here. And when I run it, the output is called specific request. You know, with method overriding, it is always the derived class version which is called, right? Now I'm giving both options. If you want to use the direct functionality, fine. If there is a device which runs directly on AC, you can directly supply the AC current. But if there is a device which needs DC current, you need adapter, which draws AC current and converts or transforms that to DC, and then supplies it to your device. Your input is going to be AC current in all the cases. Yes or no?
Yes.
Okay. So which pattern was this? Adapter. Go by the dictionary meaning. It will be easy. I hope it is clear.
Saket, one more query.
Yeah,
Regarding here, we are just giving means wrapper over that particular method, right?
correct,
In ad.
correct.
So suppose I would like to do a few other methods as well, means to give the wrapper over that, means kind of adapted.
Your
So can I
your
add this?
adapter will contain all of them.
Okay, okay. Means all the methods within the same class only, that adapter only.
Absolutely,
Even though the
absolutely.
business functionality is different one. We are not
Yeah, but
segregating that one. Yeah.
it may be different functionality, but related and working on the same set of data.
Okay. Oh, okay, got
So
it,
there
got it.
has to be some common thing into it, right? So I give you the
Yeah.
example. We spoke about the mobile charger, right?
Yes.
These days, mobile charger come with the USB port, correct?
Yeah.
Now, the same charger can be used to charge any device which finds the output current of this charger sufficient for it. You can charge your laptop also. You can charge your mobile phone also. Now, the mobile phone may have a C type port. The mobile phone might have lightning port. The mobile phone might have the micro USB port, right?
Yes.
Now, this is where your scenario comes into picture. I can have one adapter which gives me three different outputs at the same time with varying voltage also. If my device is supporting not more than 2 volts, I have one port which gives me 2 volts. There is another port which gives me 1 volt. There is another port which gives me 5 volts. Yes.
Yes.
And I can have three different interfaces. On the adapter, I have USB only, but the other end of the cable probably is very specific, like lightning port or like micro USB or C type. Yes or no?
Yeah.
Practically, you may have seen those cables already,
Yes.
right? One
Yes.
single cable originates and then it splits into multiple types, power
Yes.
different kind of devices, correct?
Yes.
For the older feature phones, we didn't have any standardized ports. They all had different ports, right? Different layout of the pins, different weight, different length. So we used to have cables with that feature also. Now, these days, it has been limited to three types only, mainly micro USB, C type, and Lightning. Because most of the devices as on today are being produced with those three interfaces only, right? But what is common in them? They're operating on the similar data set, which is current,
Mm.
right?
Means
Their functionality
yeah.
is different. Probably they are using three different types of circuits. inside the adapter. Yes or no?
Yeah.
If voltage is different, I mean the output voltage and output current is different, then three different circuits would have been built into the same adapter, correct?
Yeah.
And the different circuit might have been connected to different port. So you attach the cable and you get what you want, correct?
Yeah.
So I hope you got your answer.
Yes. 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 Yeah.
Yeah. Let's close this and move on to the next pattern, which is bridge. So in real life, what is bridge? Think of a river. There are two banks almost parallel to each other. They cannot connect to each other. But what if someone wants to go from one bank to another? That's where the use of bridge comes in, right? Connects two different worlds. Yes or no? Now here in software, what that two different worlds or two different banks will be. This is something to do with abstraction again. This pattern basically assists in decoupling the object implementation from its abstraction so that both of them can evolve or vary independent of each other. Understood? Understood? Let's get it cleared by this UML diagram. Moment. Here it is. So we have abstraction, we have the implementation. There is one operation here. But then there can be a new abstraction replacing this one. Now, the new implementation might also be needed, right? Concrete implementer A, concrete implementer B, they all can evolve independently. There is no direct connection between this and this and this, and same way this and this and this. So there is an abstraction. There is an implementer abstraction separately. So this is only for implementation, which talks about what common stuff should be there, right? Now, via this implementer, it will be decided whether it is this abstraction or this redefined abstraction which will be applicable. Looks a little complicated. Let's have an example on this and we'll understand it pretty well. So how do we start? Let's go back to Visual Studio. Solution Explorer, right click on structural patterns. Folder, add, new project, console app, next. Let's name this as 7 underscore bridge. Next, .NET 5, create, and then remove console write line statement from main. Yes. So from the diagram on the left hand side, you had abstraction and then redefined abstraction. You can actually think of abstraction being the main business object, redefined abstraction as customer specific business object. Implementer may be something which actually talks about the data. So it may be data object. Concrete implementer might be about customer specific data object, right? On the same grounds, we'll be building our sample. So let's have a class created here, public class abstraction. Now this class is going to be actually having the member of the implementer created. I mean, instance of the implementer created into it as its member. So before I go ahead with the abstraction class implementation, I go for public abstract class named as implementer. And what it contains is just one abstract member for now, public abstract void operation. Some method which does something. And then I make this abstraction class have a protected data member of type implementer class to be created by the name implementer. I have a property also created on this, which will be write only property. So here I say public implementer. The name of the property also I want to have as implementer only. And it has got only set block into it. Which contains implementer equals to value statement. So this allows me to have the choice, like which implementer I want to use. Like I can choose the contractors for any work which I want to do for my house renovation. It's not necessary that I need to hire the same contractor who probably has done some work in the past for me. I always have a choice, right? It is me who is going to decide which contractor I want to use, or in this case, which implementer I want to use. Then we have the member method here, which will be a virtual method that can be overridden by the name operation, and which simply acts as a wrapper on the implementer's operation. Whichever implementer we have selected, the operation method on that implementer will be called. Got it? Next, I have another class called as redefined abstraction. That inherits from abstraction and contains the overridden version of operation, which actually makes call to implementer dot operation. I might have some additional functionality also over here if required, before and after the call to operation, right? That's why I'm overriding. So left hand side of the UML diagram is almost done. Right hand side, the top level class implementer is present, but concrete implementers are missing. So here we go and implement our first concrete implementer. Public class, concrete implementer A that inherits from implementer and overrides its lone member operation. And what it does in that is displays the message on console.writeLine, concrete implementer A operation called. I copy and paste this concrete implementer class A, rename the copied version to concrete implementer B, and accordingly the message also I change. Just to simulate that these are two different implementations, right? Two different logics. Yes. And then comes the main method. So here I say define an object of type abstraction. AB equals to new abstraction to start with. Or we can directly go for redefined abstraction also. I want to set the implementer or I want to choose the implementer which I want, A or B. So let's say I want to start with A first. I say AB dot implementer is equals to new concrete implementer A. I say use this implementation. And then call operation method. So this operation will be called on which implementer class I have instantiated. So practically, this is the message I must be getting. Copy these two lines, paste back. Here I say now implementer is being assigned to new concrete implementer B instance and operation being called again. This time this message should get displayed. So you can see clear disconnection between the abstraction and the implementation. Both can evolve separately, right? Some lazy binding I'm using here. Yes or no? Implementer is not directly implementing the abstraction. See, the abstraction class is not implemented here. Even by the implementer also it is not implemented, right? Abstraction is different class, implementer is different class altogether. The only connection point is this, where abstraction contains the instance of implementer class as its member. And this class being abstract cannot be directly instantiated. So it allows me to set whichever implementer I want to use. Is it clear?
Saket, can you please
Yeah,
just repeat the means use of the redefined abstractions? Because we are in concrete class, we are implementing implementer class, right?
correct,
And
correct.
and we can pass the direct object to that particular While creating the object, we can
Yes.
pass the direct concrete implemented
So
a object to
what
that
you
one.
mean is if I don't go for redefined abstraction, I directly go for this.
And we
There is no problem with that also. This will also work.
Mhm.
We are passing the object in this case also, right? Here we are passing A, here we are passing B. It just works fine. But the thing is, abstraction itself can evolve over the time based on the change in need of the business, right? Like banks when
Okay.
started had only banking operations, but over the time they started providing the uh, share trading platforms as well. They started selling the insurance policies as well, right?
Hmm.
Their abstractions have changed over the years. Yes or no? So
Yeah.
apart from the banking operation, they might want the other operations to be provided as well. And that's where redefined abstraction is being used. Got my point? So here I may
Okay.
have additional functionality either before this or after this combined with it. Correct? And with interfaces being introduced, not only the abstract classes, most likely I will have more operations over here like this from multiple abstractions. Yes or no?
Yes.
Understand?
Yeah.
And when I'm creating this property may be representing banking, but I may have another property created which represents insurance, another property which represents share trading. Yes.
Yeah.
And for share trading, also the platform is of bank's choice. For insurance, also the bank has a choice which insurance company they want to tie up with and sell their insurances. Yes or no?
Yes.
That's where this decoupling is needed. Correct? Where
So
we want to
yeah.
have a choice, not a compulsion that, okay, you have to do this only. Understand?
Yeah. Yes.
Okay. Any more questions on this? So let's take a break here for 15 minutes. Once we resume, we will talk about the composite pattern followed by decorator, then facade, then flyweight, then proxy. Okay.
Yes.
Almost touching 10:50. We'll resume at 11:05, 11:05. Okay. Okay, I'm back. Shall we proceed?
Yes.
Yes.
Yeah. Okay. So next one is composite pattern. What is composite in general? The word derived from compose. So any idea what it could be?
Made up of many items.
Made up of many items, right? Now, with respect to the object-oriented programming, it is about one object having different other objects added to it. Maybe single objects, maybe in the form of some collection. The important part over here is the object must be belonging to a similar family or same family. So something like if I talk about the employee collection, it may have employee object, it may have contracted employee object, which is also an employee in a way. It may have something like very specific role specific employee types like salesperson or maybe agent or something. All are going to be the type of employee only. So one object having the list or the collection of all other related objects. This is where the pattern called as composite actually comes into picture. Definition wise, what it says is something that composes objects into the tree structure to represent the partial or maybe the complete hierarchies of those objects, right? Advantage of this is that it lets the users or the client applications or client modules treat each individual objects and compositions of those objects uniformly. So common logic basically can be associated and executed along with them, right? Individual object and compositions means their inheritances and something like that. Okay, so let's have a look at the diagram first of all. You can see this is the client app. This is the component which contains some operation and then some other helper methods like add, remove, get child. So it's all about working with the collections, right? And the object itself may have some composite object within it. It can be an independent object also at times. It can be a composite object. Each child object here can be a composite object in itself, which will have its own stuff. And that's where this relation is provided one to many, right? And there must be some iteration of this kind somewhere where we are working on each child object and probably invoking some kind of operations which is uniform. Same operation on different objects, right? So let's understand this with an example. Let's go to Visual Studio. Let's close this tab and right click on structural folder and add a new project, console app. Next, 8 underscore composite is the name, .NET 5 as framework, create. Let's remove this. And as I said, we'll be working with collections. There will be one using statement going on the top, system.collections.generic. Okay. Now, here we have the first abstract class named as component. There is a protected member into it of type string by the name as name. There is a constructor parameterized one. So I type CTOR, press tab, and then add parameter string name, which assigns the parameter name to this dot name. And then there are abstractions for add, remove, etc. So here I go for public void, rather abstract void, add, that takes in the object of type of this class itself, component C, or any of its derivatives. Same way, I have should be add, this should be remove, and then another member, public abstract void display, that displays how many objects are there in that family tree. Rather than how many objects, I say that display up to this depth, 1 level, 2 level, 3 level, 4 level, whatever it is. Display the tree up to that. Okay. And then there is a derivative of this class. So public class by the name composite that inherits component and implements the abstract members. So hover, light bulb, drop down, implement abstract class. All the three members will be introduced. Add, display, remove. But before these methods, I have a member of this class called a list of type component named as, let's say, child or children. As new list of component. And then I do have a constructor also for this class. As the base class constructor is parameterized, I need to have a constructor with the parameter here as well. So that takes in string name and change it to the base class. The base name. And then I add the code to the method add. Simply says children dot add t. Remove, I'll code first. What it does is children dot remove C and display. I need to iterate on the list of objects. So first of all, I display a message. As a new string object for which the first parameter goes as dash, which will be repeated for given number of times. What is that given number of times is represented by the parameter depth. and then I concatenate name. Okay. There I go for the iteration for each component C in children. C dot display. Whatever the depth provided plus 2. Some calculation. Okay. This is depth. So make the necessary corrections. Next is I want to deal with the individual nodes also. So here I have a class named as leaf that inherits from the component class. Has a constructor of its own that takes in string name, chains it to the base class constructor. Okay. And then overrides the abstract class members, add, display, remove. What add does is, but now displays a message, cannot add to a leaf component. Leaf means the end node is there, so I cannot add further, right? Similarly, if it doesn't have a member, I cannot remove as well. So here I say console.writeLine cannot remove from a leaf component. Sorry, this should go and remove. We'll get this cut. And paste it here. What display will have is console.writeLine, new string. First parameter is hyphen, displayed or repeated the given number of times. Depth should be depth, I guess. In component class itself, I have made a mistake. I'll do the correction. Yeah. So let's change this here. Everywhere else, there will be no problem. And then I say concatenate name to it. Save. Now it's usage in the main method. So here we go and create the instance of composite class. We name it as root. If it is a tree structure, there has to be a root where it starts. I say new composite. The name goes in as root. root dot add method I call. I add a couple of leaves over there. So I say new leaf with the name leaf A and then leaf B. I create another composite component, composite, let's say by the name comp equals new composite. This time the name I gave as composite X. And this composite is going to have some of its own members in the form of leaf. So probably I copy these two statements, paste here. First change will be replace this root object with comp on both statements. And then I say this is leaf A for X component, so XA, and leaf B for X component, so XB. And then I add this component to the root. So here I say root dot add comp. Then I say root dot add new leaf, leaf C. Again, directly to the root, not to the child component. Okay. Then I create an independent instance of leaf by the name leaf equals to new leaf. I name this as leaf D. I add this also to the root. So this is just another way how to add the leaf components. So I say root dot add leaf. This way I can remove the leaf also. So I do say root dot remove same leaf component, leaf. Then I want to display the recursive tree. So here I say root dot display 1 up to a depth of 1. Okay. So just imagine that tree structure here. Try drawing it on the piece of paper. Start it. Root. Then we have leaf A, leaf B at level 1. Root is at level 0. Leaf A, leaf B is at level 1. Then composite X component is at level 1. But then leaf XA and XB at level 2. Then leaf C back again at level 1. Right? Got it? Where is the recursion logic in this? If you see the display method in component class, display method, calling display method again on component type only. This is where the recursion is happening. It calls display method. Now, if that component itself is a composite component, it will again go for iteration. If it is a leaf component, means node component, individual one, then the display method from here will be called, and only one time console write line statement will be executed without iteration. Understood?
Yes.
Any questions? Mostly this will come handy while working with collections, right? Object families. Okay. Let's move on to the next one, that is decorator pattern. What is the dictionary meaning of decorator, by the way? You purchase a new house. You start using it as it is, or you do something before moving in? A simple question it is. Anyone can answer.
Yeah, we do some interior and those.
Yes, I do some decorate. I
It
mean,
may be
say,
proper furniture and proper interior decoration that you do, even if that is not possible at the moment. Usually that happens with the very first home that we purchase, right? Budgetary issues might be there initially if we are at the beginning of the career. In that case, also, we do at least the basic level of decoration, isn't it? To make the house look nice.
Yes, right.
If not detailed decoration, basic decoration at least is there. Maybe some stickers, maybe some wallpapers, maybe some frames, right? Paintings. That also adds to the decoration. Yes. So your object is your home. Now, whatever else you're putting in to make it look nice means ultimately give better feel to any visitor, including yourself, is all additional thing that we are putting in. Yes or no?
Yes.
Let me
yes,
stay in that home. Do I actually need paintings? Do I need wallpaper compulsorily?
No.
No. Fans, lights, ACs probably is not something which I'll put in decoration category. That's a necessity. So that is expected as the part of the home. Yes or no?
Yes.
Mandatory functionality, I would say, of the object that is called as home. But anything else like carpets, like furniture, like wallpapers, paintings, decorative lightings, or any other decoration material, this is not necessity. Without that also you can stay there. But it adds to the look and feel of your home, right? People start feeling good while visiting. Yes.
Yes.
Any family member when visit, like elders, maybe parents, if they are staying at a different location, they also feel good if the house is nicely decorated, right? So logically, the concept of decorator in the software, in the code also is the same. It is not about the mandatory functionality that an object possesses. It just gives some additional responsibilities to the object on need basis. So if required, I have it. If not required, I don't have it. Right? With interfaces, with abstraction, partially this may be possible, but again, interfaces may have multiple mandatory functionalities within it, right? That will not look good. I mean, it will be forced on me to implement all the members of the function, of the interface or of the abstract class. Yes or no? I'm looking for completely optional stuff. What I want is what I'll use. What I don't want, I'll not use. That's where decorator helps. So say for example, if you have worked with .NET in the past, you might have worked with some custom attributes. The most common attribute is serializable. On some classes you see in square brackets, it is mentioned as serializable. If it is not present, the object of that class cannot be serialized, means the instance cannot be preserved, right? But if it is having that attribute on the top, then you can call serialize method on the object of that class and the object state can be preserved. It can be again retrieved back also by calling deserialize method. Now, whether serialize, deserialize will work or not, it all depends on whether the class itself is defined as serializable or not. Understand? So this is something where the decorator pattern seems to be being used. Serializable attribute or any attribute for that matter is actually a decorator. The object need not behave the same way all the time. You can change its behavior by the presence or absence of the decorator item. How you implement decorator in a specific language depends on the language, depends on its syntaxes. In C Sharp, in .NET languages, it is done with the help of custom attributes. Understand?
Yeah.
Let's understand with the help of some sample code. In this case, we'll not be using custom attribute. We'll be using it in a very generic manner so that across any programming language, you will be able to implement it. The languages which don't support attributes also, there also you will be able to implement it. So let's say add new project under structural folder. Let's select console app. Next, 9 underscore decorator is the name. Next, .NET 5 create. Remove console write line statement. Okay. Then here goes my first abstraction. Public abstract class named as component. It contains a single member as abstraction. So public abstract void operation is the single method here, single member. Then I have my concrete class. I do say public class concrete component that inherits from component abstract class and implements it. So here I right click. In fact, just over, use the light bulb, implement abstract class. Operation method is introduced. And here I say, remove this, throw new not implemented exception, replace it with console write line statement, which displays the message concrete component dot operation method invoked. Simple thing. Till now, it's just simple abstraction uh, based implementation. Now, the real stuff starts here. I have another abstract class named as decorator. That also inherits from component. has got a protected instance of component class within it. One of the pattern we are using here. Remember which one? Adapter, right? Component. Then here I have public void set component, or instead I can have the set only property, means write only property. So let's say public component or void. No, it should be of type component. Component is the name. It has got set member where it sets the component equals to value. Yes. And then here I want to override. Let's type override space. From the list, double click on operation. I want to override this method where I have a statement, if statement, which checks if component is not equal to null, then component dot operation should be called. Okay. Next, I want the implementation of this decorator class and where I want choices. Here I go for public class C decorator for concrete decorator. A that inherits from decorator. And there it overrides operation again. It calls a base operation method and puts the additional code within it, which displays the message concrete decorator C decorator A dot operation method invoked. Let's copy this class C decorator A, paste it here, change the name to C decorator B. Message also changes to C decorator B. Now this might have some additional operation here. Let's assume it has been added already. So I make the call to additional behavior or additional operation, whatever you call. And then here I actually get it created as a private helper method. Private void additional behavior. But now it just contains a console write line statement. Additional behavior method invoked. And this is from C decorator B only. And so I'll say C decorator B dot. Okay. Then comes the main method, wherein I create the instance of concrete component. C equals new concrete component. Now I say C decorator A D1 equals to new C decorator A. Same way, C decorator B instance I create by the name D2 as new C decorator B. And I say D1 dot set, rather D1 dot component equals C. D2 dot component also is set to C. We can set it to D1 also, in fact. And then I say call operation on D2. Just go through the code and tell me what is the output that is expected here. Functionality wise, only one functionality being called, that is on D2 object operation. D2 component is D1. D1 is of type C decorator A. C decorator A is this. We do have operation method here, right? And it calls base class operation as well. We are inheriting from decorator, so here it goes and calls operation and calls on the component path. So that is D1 component only, right? So ideally, everywhere we are saying base dot means this operation has to be called first. This is the output that we should be getting. Then decorator A operation, then decorator B operation. In between, we should have this also displayed. Let's have a look. Right? Let's do a debug execution. That will be simple. I just put the breakpoint right on the first line in main method and start. So it's waiting here. Let me reduce the window size. Okay, no output for now. I just press F11 key. Move to the next. No output should be there on console. Decorator A object is created as Devon. No output. Decorator B object is created. No output. D1.component being set to C. Say yes here. D2.component is being set to D1. And then D2.operation. So where it comes first? D2 is decorator B object, right? D2 itself is decorator B object. Here is the operation, which says base.operation. Base is decorator class. So here if I say F11 again on base.operation, it goes to the decorator class and calls operation method from there. checks if the component is instantiated or not. It looks to be instantiated to C decorator A instance. Hence, because it is not null, it goes and calls decorator A operation method. It comes to decorator A operation. Here also again we have base dot operation. Again decorator is the class, and here if I see component, this time is just concrete component instance, right? Not equal to null. And it says component dot operation. This time it goes to concrete component operation method, gets it called, and displays the output here. Back over here where the operation was called in decorator class. Back over here where this operation was called in decorator A. Then it displays C decorator A operation invoked, returns, and this execution is finished. Then additional behavior gets called. The output is displayed for additional behavior. And then we also display C decorator B operation invoked and exit. So this is the final output. Right? To understand the flow, this breakpoints and debug execution is very, very useful. Yes or no?
Yes.
Now see, if I don't want D1 to use the component as concrete component, I don't set it simply. Like for D2, I didn't set it to C. I said D2.component equals to D1. What if I don't set anything? I don't set this, I don't set this. And just call D2.operation and see the output. I still have it invoked as the basic input without fail. Yes or no? So conditionally, I'm able to decide what should be loaded into my component, what should not be loaded to my component. Am I right?
Yes.
Attributes further make it easy in .NET. Okay. For now, the concept of attributes is out of scope for this particular session, but you can explore that. Just make a note. This decorator pattern can be more effectively implemented in .NET code using attributes, custom attributes. For that, you just need to know how to work with custom attributes. Millions of samples are available online. You can just go through any one of them. Yes. Let's move on to next one, that is facade. What is this facades pattern? What is the meaning of facade, by the way? Anybody knows? Facade actually represents face. So if applied to building, how the building looks from the front. If I talk about person, the face of the person is his facade, which also includes the height and the other physical parameters. Yes.
Yes.
Okay. The look and feel in front. Now, with respect to objects, where this will be applicable? What this object provides me, what functionality it provides me. So the set of interfaces to interact with that object will represent the object's facade. Is it clear? Externally visible members. Externally visible means via object also they can be called, right? This will be a single unified interface, which might be based on the set of other interfaces into the subsystem. So at the end user is not going to need to go through different interfaces at his end, right? So something like gateways we build, or what we can say is like there are hundreds of web services that needs to be invoked, and we put a object in between which just combines all those web services, and we provide the URL of this object back to the client. Gateway implements this concept. Your load balancer implements this concept as well. Load balancer act as a facade to the subsystem. Gateways act as a facade to your subsystem. So the end user need not know the complexity and the real implementation, which also helps in the code security. Yes or no?
Yes.
That's something what we call as facade. So let's have a look at the UML diagram here. Subsystem might have different interfaces having different functionalities, right? These empty boxes are those interfaces, individual services. And then there is a facade which just provides the externally visible face of it. It knows where these interfaces are, where their implementations are. But the users of facade need not know. They just need to know facade. Is it clear?
Yes.
Okay. Now, suppose you are actually looking to get some loan. You have to mortgage something with the loan provider, right? Now, here, as a typical end user, you just need to know how to apply for loan, or maybe you can call it as mortgage application. Yes or no? Mortgage application, loan application, whatever. You need not know the actual subsystem applicable. Behind scenes, there will be a bank, there will be your credit score, there will be uh, the actual loan processing itself, different other departments, document verification and all. Now, take this as an example where you are actually going with your requirement to a direct sales agent, DSA, instead of going to a specific bank, because you don't know which bank will give you the best possible interest rate and best possible deal. So you go to DSA. DSA does his own research of all the offers from all the banks and probably gives you the best offer. And you actually need not know where the processing is happening. He will do all the communication in between. So this DSA is actually going to be the facade for the banking system, the whole process. Yes or no? He must be in contact with multiple banks, multiple loan providers, banks, NBFCs, etc. Right?
Yes.
Same is the case with the websites or the portals like Clear Trip, Make My Trip. You put your requirement with them. They are connected to the different airlines. They give you the option. You select your flight which is suitable to you. You do the billing with the service provider like Clear Trip or Make My Trip only. Ticket booking is done by them for you, right? You need not know exactly how the airline booking system is working. The other way around, you have to go to the portals and websites of each and every airline to see and find the best possible deal and something that suits your requirement as well. Yes or no? Which is easier,
Yes.
going with Clear Trip, Make My Trip, or going with individual airline websites?
Going with Make My Trip and those kind of apps.
Aggregator platform, right? So these aggregator platforms ultimately, don't you think, are the face of the reservation system? And that's where we use the term facade. They are actually implementing facade pattern. So any system complexity can be hidden behind a facade. And this is not for actual end users actually. This is mainly for your team members, other team members who might be working on user interface of the application. And you are working on the business logic part of it. You don't want them to be involved in the complexity of the business logic. You want to hide that. And you want to give them easy interfaces where they can put in their call and they can get their work done. Got my point?
Yes.
Okay, so let's have a look at the example here. Let's go back to Visual Studio, create a new project under structural, add new project, console app, next. Let's name this as, what's the sequence number going on? Should be 10 now, right? I say 10 underscore facade. Next, remove this console write line statement. Okay. Let's build some sample classes that represents our subsystems to start with. So here I have my first class subsystem one. Let's spell it out. Which has got a single operation as its member, public void method one. Has got a single statement console.writeLine, starts with a space, subsystem one method. Let's copy this subsystem one class, paste it here, rename it to subsystem two, rename the method one to method two, and in the message also, this is subsystem two method, right? Paste it again and do the renaming. This is going to be subsystem three class, method three, and this is subsystem three method. One more subsystem I'll create. Again, paste, change this to subsystem four, method four. Subsystem four. Right now, if I think of using these methods, I have to know all the four classes. I have to know all the four methods. And separately, I have to call all of them. Yes or no? I have to instantiate four objects for working with these four methods. Yes or no?
Yes.
In my main. Rather, if I delegate that task to a separate object, which does it for me, and use that object in main, don't you think it will hide the complexity? I need not know how many subsystems are there. It will just provide me single interface where I can put in all my requests. Call method 1, method 2, method 3, method 4. That's it. I'll have only one object of this intermediate object. This intermediate object is what we will call as facade. Hence, I name this class as facade. What I have is here I have the instances of each of those subsystem classes. Subsystem 1, say I name this as 1. Same way I say subsystem 2, 2, subsystem 3, 3, subsystem 4, 4. And then I create my actual interfaces. Let's say here I have public void method A. My requirement is like not calling individual methods, but in combination also I might need them. So that combination calls also I can hide behind these methods. Let's say this displays me console.writeLine, new line, method A, dash, 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 just for our understanding. And I say one dot method 1 is invoked here, followed by 2 dot method 2 is invoked here, followed by 4 dot method 4 is also invoked here. As I said, a combination may be required, right? Then I have another combination represented by public void method B. This represents some sort of workflow, isn't it? Say console.writeLine, new line, method B, dash, 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 dash. Here I want to say 2 dot method 2, followed by 3 dot method 3. Different combinations I can create like this. And this way I'm hiding the complexity, like in what order the method should be called and all. I, as a business logic implementer, better know the workflow. I set it up. And the user just needs to instantiate this facade class and call the right methods there based on the requirement. So this represents the high level functionality, right? Call this method for this purpose, call this method for this purpose. Behind scenes, what all dependencies are required, it is taken care of. Got my point?
Yes.
So how the main method will look like here? It instantiates facade. As I said, the end user will be doing this. End user means the next developer, right? Developer or developer's team who are probably working on the user interface or something. And then with the help of this facade, let's say they make the calls to method A and method B as per their need. Facade.method A, facade.method B invoked. Let's start. Did I miss something? Oh yeah, we didn't instantiate them, right? Yeah, I forgot to put the instantiation code. So let's add a constructor here, which says 1 equals to new subsystem 1, 2 equals to new subsystem 2, 3 equals to new subsystem 3, 4 equals to new subsystem 4. And then start again. Method A, this is only for the understanding that it is showing that, okay, subsystem 1, 2, and 4 are called here, and 2 and 3 are called here. In reality, this is not something we will be doing. It will have some real business logic in place. Yes or no?
Yes.
Make sense? So what was it? It was the pattern called as facade. Got it? Next is flyweight. Anybody knows what it is?
Saket, one more thing
Yeah,
regarding the facade actually.
yeah.
So we have created the different classes, and instead of doing this, we do means within the facade class,
Hmm.
each and class will have the interface implementation, and that interface will be within
Yes,
the
we can.
yeah, means it
We
will
can.
be segregated as well, and it will be
Absolutely. So what you're talking about is actually integrating more than one design pattern into each other. So that is possible. See, we have already learned the creational patterns and some other structural patterns. So you can actually mix and match as per the system's requirement. Why I'm not doing that right now in the examples is just because we want to focus on one pattern at a time. In
yeah.
reality, single patterns are not going to be used alone. They will be used in groups only, right?
Mm. Yes.
So definitely you are thinking in very, very right direction. There is no problem with it. You can improvise the things, right? It's just like jigsaw puzzle. You have some 24 patterns as 24 pieces of the jigsaw, and then you need to connect them to each other to make full usage or optimized usage of the patterns within your application. And it's not necessary that each and every pattern would be applicable in each and every project and solution. But my point,
Yeah.
you have to analyze at the architectural level that which pattern will suit my requirement and where. Whether it will be used alone, whether it will be used along with some other pattern, combined with some other pattern, or how is it? So that analysis has to happen. But that can happen only when we know each and every pattern, right?
Yes. Yeah.
Individually, if we know them, their combinations we can try out. And with those combinations, the further combinations can be made. Correct?
Yes. And
Okay.
one more thing, yeah,
Yeah.
means or we have repository pattern as well, and within that
Yes.
we have unit of work as well. So unit of work is kind of
Correct.
facade as well, right? Means because we are
Absolutely.
having yeah,
Absolutely. So unit of work is more precisely defined for a specific type of task only, right? But
yes,
at the high level, it is actually facade. Am I right?
yes, mm,
It hides the complexity of interacting with the databases, right?
yes,
So core level, it's facade pattern only.
yes,
And then we have a composite version of it, like combined with the other patterns and then having a different name to that combination. So repository pattern also is not actually a core level pattern. It's more of a composition of other
oh,
patterns, right?
other pattern, yes, yes, yes,
And because you are using it in a specific way, in a specific scenario, a different name has been given to it. Correct?
Yeah.
So even if when we talk about MVC, MVC also is a pattern, isn't it? But
Yes.
it's not a core pattern. It's a high level pattern which probably uses multiple other core level patterns into it. Correct?
Yes. Yeah.
Okay,
Thanks. Thank you.
let's move on. Next is flyweight. So anybody knows what is flyweight? Flyweight has something to do with lightweight. Flyweight means the weight which can fly. So definitely it has something to do with lightweight. Now, with respect to object, the term lightweight or flyweight will be applicable when we actually discuss about its memory utilization or memory consumption. So the objective of this pattern basically is to minimize the memory usage by a certain object, probably by using the means for sharing some of the data with other similar objects, right? Common data we can pull out, maybe we can have the entire data structure split into multiple data structures so that the common portion can be shared by the different objects, right? And this way we will have more optimized utilization of the memory. At the end, we can create and use more objects into the limited amount of RAM available to our application. RAM is not unlimited, right? So we have to see exactly how we can optimize the usage. Yes or no?
Yes.
Have a look at this diagram. This is the shared object portion. This is unshared one, maybe very specific requirement. And when put together, they represents the complete flyweight. We have flyweight factory, which probably creates the instance in such a way that it contains the shared, unshared, both type of data available together with one single object, and client just consumes that. Make sense? Common state goes here, specific state goes here. It's all about splitting the object representation. Yes or no? Let's understand this by example. Create a new project here under structural patterns. Add new project, console app, next, 11 underscore flyweight is the name. Next, .NET 5, create, get rid of this console write line statement. We'll need the collections to be used here, list basically. So let's import system.collections.generic. Okay. Let's create our first abstract class here that represents the flyweight object. So public abstract class flyweight. Just a single abstract member I'll put into this public abstract void operation that takes in a parameter, let's say integer type with the name extrinsic state. This is for the simulation of how many members will be put into the extrinsic state, means unshared, or I would not unshared, shared object or shared mode. Here goes the concrete version of it. I say public class concrete flyweight. Inherits from flyweight and implements the abstract class. What the method does is simply for now displays a message as an interpolated string, concrete flyweight, colon, curly brace, extrinsic state, shared state. And then I have another class, copy of this. This I'll name as unshared concrete flyweight. Inherits flyweight, operation method, and here this is unshared concrete flyweight. Here it is, the count of the data items which are not shared being displayed. So here you can see there is a split. The common data goes here, uncommon data goes here. Now this class probably might have multiple implementations, or there can be multiple unshared versions which will have their specific data members into them. Common data members of all of them will be promoted to this concrete flyweight. So the memory utilization will be fully optimized. Okay.
Yes.
Now let's go to the other class which will actually provide this combination. Maybe you can think of this class being the facade for whatever we have put for now. I'll say this is flyweight factory. Okay. It contains a data member private of type dictionary, key value pair basically, where key is going to be of type of string and value is going to be of type of flyweight. I name this as flyweights. I make this available as a auto implemented property and get it initialized to new dictionary of string flyweight. There goes the constructor. What it does is adds to the collection flyweights dot add. The key is X, comma. The value is new concrete flyweight. Flyweight itself cannot be added being abstract class. 3 concrete flyweight objects I'll add like this. So X, Y, and Z. Then I have a member method here, which returns the flyweight object, public flyweight by the name get flyweight, based on the key that is given as input parameter. And here we say return flyweights of key. This will be a flyweight object only, right? The purpose of this is to create the flyweight objects. Then we go to main. We create a variable by the name extrinsic state, assign a number to it, let's say 22. Instantiate flyweight factory equals new flyweight factory. Then I say var fx for flyweight x equals to factory dot get flyweight x. And call the operation method on it. Pass extrinsic state to it. Also reduce the value of extrinsic state by 1. So that is for basically, okay, I've worked upon this object already, hence I'm reducing the count. And then I copy the same thing, the 2 lines, paste here, change this to y, fx also change to fy, here also. And same thing I do for z. Again paste, change this to z. This is fz, this is fz. Okay, this is straightforward thing. And then I go for creating an instance of unshared concrete flyweight by the name fu equals new unshared concrete flyweight. Call operation on this, pass minus minus extrinsic state to it as well. And let's try. So count, we can see whatever is going in 22 to 21 to 20 to 19 and to 80. So unshared concrete flyweight objects also are able to use the data provided by shared components, but they have their own data members separately available. They can work on their own data, plus they can use the shared one. This is the whole idea, right? So it's just simple mathematics rule. You can see if I have an equation which reads as a multiplied by b plus b multiplied by c, how can you simplify this? I repeat, a multiplied by b plus b multiplied by c. What is the simplified version of it?
B
Can I
will be
write it
common.
like this? Yeah. So original equation is a multiplied by b plus b multiplied by c. Can this be rewritten as P within parenthesis, I say